Alright, here we go. So we're going to graph the quadratic function in standard form. So standard form is ax squared plus bx plus c. So let's take a look at what we have first. So for our worksheet here purposes, we're going to identify a few items here. We're going to identify what the a value is on this f of x equals x squared. This is known as the parent function, right? Because I really don't have anything else besides this x squared. If we look at some of the other ones here, we're going to look at, we have 2x squared minus 11x plus 15. We got 2x squared plus 1x minus 3. But this one is just your very basic one. This is the parent function. So technically this is 1x squared, if you want to think about it that way. So this is a 1x squared, so my a value is 1, plus 0x, so my b value is 0, and then plus 0 here, which is my c value is 0, right? So the b and c are both 0, my a value is 1, and you just get 1x squared. All right, let's get a couple more pieces here. So we have this function, and this is called quadratic function, like we said. It could have x-intercepts. It could have something, this is an abbreviation. It says axis of symmetry here. So axis of symmetry. Okay, and a vertex. The vertex can be found the same way for every one of these functions. Okay, so for the vertex, I'm going to give you a formula here. X equals negative b over 2 times a. Alright, and this is going, and notice however x equals and not anything else. Alright, so this gives you the x value of the vertex. So if you plug this in, well, negative b, which is just negative 0, over 2 times 1, and 0 divided by anything is just 0. So the axis of symmetry is at, the x value is 0. I'm sorry, the vertex, the x value is 0. And then once you have the vertex of the quadratic here, then automatically your axis of symmetry is just going to be feeding off of that. So x equals 0 is the axis of symmetry, and I'll show you what that all means on the graph in a second. Okay, so this x equals negative b over 2a gives me the x value of the vertex. The x value of the vertex is where the axis of symmetry occurs. This is going to be a line, okay, and I'll show you how that looks like. And then once you have this x value of the vertex, then you can just go back and plug in 0 into your function. So you're going to find what f of 0 is. Well, that's easy enough, so I'm just going to plug in 0 for x, and 0 squared is just 0. So when x is 0, y is 0. And that's why so my vertex is 0, 0. And for most parent functions, the vertex is at 0, 0. Okay. So your x-intercepts, you just notice that this is, your vertex is 0, 0. So you have an x-intercept at 0, 0, and a y-intercept at 0, 0. And you'll see that soon, okay? So far, this is what I have. I have x-intercepts, I have axis symmetry, and a vertex. So I'm going to plug in my vertex here at 0, 0. Go a different color here. Alright, and I want to start graphing this thing, and what I'm going to do for myself is just make myself a little table of values here. And if x is 0, so since I know what my vertex is, I'm going to give myself some other coordinates here. So I'll come back to the y-intercept and reflection point. It doesn't really apply so much on this one, but I'll make myself a little table of values here. So x and y. If I go 0, and then 0, we said that one, right? What happens at 1? So what's f of 1? So f of 1 is just equal to 1 squared. And 1 squared is just 1. So when x is 1, y is 1. What about when x is 2? And I do f of 2. Well, this is just 2 squared. And so when x is 2, y is 2 squared is 4. So when x is 2, y is 4. And I'm going to go back. I'll do one more. I'll go 3. F of 3 is equal to 3 squared, or 9. So when x is 3, y is 9. So you see the right side hand of this graph here, and I can go the other side. I can do negative 1, and f of negative 1 is just negative 1 squared, which also is 1. So you should notice, you should see the reflection here. So and when x is negative 2, negative 2 squared is 4. And you see how these are all matching up? That's because there's a reflection going on, and negative 3 is 9. So negative 2, 4, negative 3, 9. And this is going to make a U-shaped curve here. Right, it's going to look like a U. And that's what that parabola looks like, a U-shaped curve. And the axis symmetry that I was referencing before is just a horizontal line going through x equals 0. And that pretty much just says that there's symmetry going on. So when x is, when you're 1 unit to the right of the vertex, you're 1 unit up. When you're 1 unit to the left of the vertex, you're 1 unit up. Right? Which is why When x is 1, 1 unit away from 0, your y value is 1. When x is negative 1, again 1 unit to the left of 0, your y value is 1. And the other numbers work the same way. Wait, when x is 2, I'm 2 units away from. When x is 2, I'm 2 units away from the vertex here. So 2, 4. When x is negative 2, 2 units to the left of the vertex, so y is 4. And that's always going to happen here. So you always have some symmetry here. Okay, and as we get to some later points, we're going to talk about the y-intercept and this reflection point, meaning that there's a symmetric point. We don't have a y-intercept. I mean, we have an x and y-intercept here going on at 0. So we're going to ignore this for now. But again, a point and a reflection point. If x is 2, we said y is 4. Right, so we're just going to highlight this point here. When x is 2, y is 4. The reflection point will be negative 2, 4. Right, and there's always a reflection there. Or you could use 3 and 9 and negative 3 and 9. Right, it's a reflection point. So once we find the y-intercept, we'll be able to reflect it on this axis of symmetry here and find the other coordinate. But you'll see that in the other examples. All right, so low table values here could definitely be helpful. And let's see what else we got here. We're going to bring back some memories, domain and range. Again, domain and range. Domain. What can you plug in for x? And into x squared, you can plug in anything you want. Right? So your domain is just from negative infinity to positive infinity. And again, we're using integral notation here. There's no holes in this graph. There's no vertical asymptotes. Right? This is just an axis of symmetry. It doesn't, it's not a break in the graph. It's just saying that there's symmetry on that line. Right? We draw it the same way as a vertical asymptote, but not, but it doesn't have the same meaning. My range, what's the lowest this graph will go? Well, my lowest point on this graph is here, at this coordinate here, at 0, 0. So the lowest y value is 0. The highest y value, well, it's going straight up, and they're both going to infinity here, so it's going to infinity. And is the vertex a max or a min? Well, the vertex is the lowest point, so therefore it's a minimum. Right? And then where is the graph increasing? Well, if I look at what the graph is increasing here, I'll try to sort of highlight it here. The graph is increasing from this part on, right? It looks, as my x values get bigger, as my x values continue from 0, at 0 to 1, my y value goes to 1. Then as I go to 2, my y value goes to 4. Go to 4, go to 3, my y value goes to 9. So as my x values get bigger than 0, my y values are going to positive infinity. So where is it increasing? It's increasing from the interval of 0 to infinity. Where is the graph decreasing? Well, if I'm reading this graph from left to right again, right, so I'm going to see that my graph here is going as the x values get smaller and smaller, or get closer to 0. So here my x value was negative 3 and my y value was 9. Here my x value is negative 2, my y value is 4. So as my x values start to decrease, so negative 3 to negative 2 to negative 1, my y values are just going down and down and down until I get to 0. So my graph is decreasing from negative infinity to 0. Where is f of x greater than 0? Okay, so where is my function greater than 0? So where are the y values, right? It's another way of saying where are the y values greater than 0? So again, this is where is the f of x greater than 0? Where is the function greater than 0? I'm referring to the y values. Where are the y values greater than 0? For which x values is the y values greater than 0? Well, every y value on this graph from here to here is greater than 0. And the other part of the graph that has all positive y values is this piece here. Right? All the y values here are positive. The only part that's not positive is my vertex, right? Because the vertex is at 0. So everything but the vertex would satisfy where f of x is greater than 0. So to write that, to say everything but the vertex, I'm going to say, well, from negative infinity, or everything but the x value of the vertex, up to 0 has a y value greater than 0. Union, then on the other side of 0, right, so if I'm looking at the left side, right, sorry, read the graph from left to right, so all this has a positive x value, a positive y value up to here, jump to the other side of 0, starting at 0.1, so anything from 0.000, as close to 0 as possible on the right side, all the way to infinity, has a y value of greater than 0. And then the other part, the second question is, where is f of x less than 0? There are no y values on this graph that have a y value less than 0, so in this case, none. Alright, so this is our parent function. Let me show you another function, or another quadratic function that's not the parent function, so we can see the difference. So here's another one we have here. Okay, so we have 2x squared minus 11x plus 15. So my a value is 2, that's my coefficient in front of x squared. My b value, be careful, is negative 11, the coefficient in front of x, and the c value is 15. Alright. X-intercepts, axis symmetry, vertex, all that good stuff. Okay, so let's get some easy ones out of the way. So the c value, in this case, the plus 15, is also your y-intercept. So 0, 15. So that's what you get from this this form here, standard form, right? Because if I plug in, if you have a y-intercept, it's when x is 0. So if I plug in 0 to my function, so f of 0 equals 2 times 0 squared minus 11 times 0 plus 15. Well, this goes to 0, this goes to 0, and you're just left with f of 0 equals 15. So there's 15. We'll talk about this reflection point in a minute, but we'll get this after we get the vertex and the axis symmetry. Okay, so this is what the c value will do for you in this form. Different forms give different different example or different pieces of the function here. Okay, so let's see what we got next. Our vertex, x-intercepts, it's easier to do the vertex first. So the vertex, again, we're going to use that formula, x equals negative b over 2a. Remember, this only gives you the x value of the vertex. You still have to plug in and get the y value. So if I use this, I get negative b, which is negative 11. So negative b over 2 times a, which is 2 times 4, or 2 times 2. So you get 11 over 4 is your vertex. So 11 over 4. Make that a little nicer. Alright, so again, negative b, so my b value is already negative, so it becomes positive. And then 2 times 2 is 4, and you get 11 over 4. So that means for my y value, I need to go in and plug in 11 over 4 into my function, right? And you can plug that in with a calculator, or you could do the mental math. Either way, I'll give you a second to do that. Alright, so plugging in into your calculator, you should get a negative 1/8, or however you did it, or negative 0.125. Right, either one. So now my vertex is 11/4, which is 2.75 and 0.125. Alright, so I'm going to plug that into my calculator, or my function here. So here's 1, here's 2, here's 3, 2.75, and negative 1/8, I'm going to put it somewhere around there. Alright, so there's 2.75 and negative 0.125. Or fraction-wise, however you want to put it. Okay, so there's my vertex. So once you have the vertex, or the x value of the vertex, remember your axis symmetry now is 11/4. And at 11/4, right at the vertex here, I'm going to draw my line there, so that's my axis symmetry. And you can bring that all the way up. Okay. What else we got? X-intercepts. Alright, so x-intercepts, we're going to factor this. Okay, so I think that'd be the first thing to help me. So can we factor this? Can we factor 2x and see if there's any factors of 15 and 2 that give you 11. So let's see if this one factors nicely for me. Let's go 2x and x, 5 and 3. Yeah, so we got 3 and 5 here. Negative, right? 2 times negative 3 is negative 6, and negative 5 and negative 11, and that gives me my 15. Okay, so before I go into finding my x-intercepts, this first form here, this form here is my standard form. And I'm going to introduce another form to you. This is called your factored form or your intercept form when it's in this notation here. Alright, so sometimes this is given to you, which is nice. It kind of did the factoring for you. So this is factored form or intercept form, is either one. Alright, so just so you recognize it, so they already factored it for you. Alright, and they pretty much put it in a form that you can easily find your x-intercepts with. So to find my x-intercepts, I'm going to take my equation set equal to 0, right? So I'm going to take my 2x minus 5 quantity and quantity of x minus 3 and set equal to 0, which then just leads me to setting each one of these equal to 0. And if I solve this, I get x equals 5/2, and x equals 3. So at 2.5, or I'm sorry, at 5/2 or 2 1/2, and 3, I got my x-intercepts. So 2.5, so 1, 2.5, and 3. I got my x-intercepts. So very tight in there. So, okay. So again, 2.5, 0, and 3, 0. X-intercepts. Perfect. Now, if you notice, and this should happen all the time, your vertex is 2.75, right? We said 2.75 or 11/4. And if you notice how far away, your 2.75 here is, right? This is where your vertex is. 2.75 is exactly quarter, 0.25 away from 2.5, and 2.75 is exactly 0.25 away from 3. And that should happen, right? This should be the same distance away from both your x-intercepts. Your vertex is going to be exactly in the middle of both your x-intercepts. So it should be the same distance away. So 2.5 from 2.75 and 2.75 to 3 should be symmetric to one another, right? Because that's what the axis of symmetry does here. So we also said the y-intercept is 0, 15. Well, how far away is 0 from 2.75? Right? If you think about that, 0 and 2.75, right? It's 2.75 units to the vertex, right? Is 11/4. So the y-intercept is 0, 2.75. So here's 0, I'm going to count up to 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So here's 15, right? 0, 15. And what I'm saying here is if this is 2.75 units to here, right? So this y-intercept is 2.75 units to the left of the vertex, the x value of the vertex. Well, if I count 2.75 units to the right of the vertex, so if I count 2.75 and 2.75, right, so if I'm at 2.75, if I count 2.75 units to the right, this is going to bring me to 5.5. So 3, 4, 5, 5.5, right, which is going to be 2.75 units to the right of this. Then this is how I get my reflection point. Right, so 2.75 to the left, so my vertex is again 2.75. Right, so 2.5, from 0 to 2.75 brings me to a y value to 15. So if I go to the right of 2.75, which brings me to 2.75, will also bring me to a y value of 15. And this is going to be, we said 5.5. Right, and that's also, so here at 5.5, if I bring this all the way up, 5.5 is also going to have a y value of 15. And that's kind of how I use my vertex here to get different coordinates, and a reflection point here. The x-intercepts are always going to be in the center, or one's going to be, the same units away left and right of the vertex. The reflection point and the y-intercept are always going to be the same units away, to the left and right of the vertex. So now we have the vertex, 2 coordinates here. That's more than enough to graph this, okay? And then you could just graph this here. I'm going to change this. Again, I'm going to do my best to draw my U shape here. I get my U coming up and then going up this way. Alright, so there's my U-shaped curve. Alright, so now I have the x-intercepts done. I have the axis of symmetry. I have the vertex. I have the y-intercept, right, which I got from my C value. I got its reflection point. How far away am I from the vertex? 2.75 units. So I'm going to count another 2.75 units and get the same y value. And now my domain range. Domains are easy. You can plug in anything you want for these. There's no negative infinity to positive infinity. I don't have to worry about any fractions here, right? It's just a quadratic. You can plug in anything you want. The range is how high or how low does this graph go? Well, how high does this graph go? It goes to infinity. How low does this graph go? I'm going to use the y value here of my vertex. So I'm at -1/8 or -0.125, whatever you want to use, and I go to infinity. Be careful here because I'm including the -1/8 here, right? So I'm allowed to equal this -1/8. And it brings back, so therefore this is going to be a bracket. So bracket -1/8 and then to infinity. Is the vertex a min or max? Again, it's going to be a minimum here because it's the lowest point. Where is the graph increasing? So last time we did it from 0. This time when we use from my vertex, it's increasing from at the vertex, not doing anything. Right? So here 1/8. Slow there, sorry. Okay, so negative 1/8 to, so from here to infinity, it's increasing. So from my vertex all the way to infinity, it's increasing, going up this way. Right, so as my x values are going to get bigger and bigger and bigger past the vertex, they're going, y values are increasing. As I'm getting closer to my vertex from the left, right, where is it decreasing? So from negative infinity all the way to my vertex, the x value of my vertex, the y values are going down. Right? They're all going down here. Where are the y values greater than 0? Okay, so we have a couple pieces here. So, excuse me, the y values are greater than 0. So on this part of the graph here, from here to here, the y values are all greater than 0. And then there's a piece of the graph here that the y values are less than 0. So if I'm looking at the highlighted pink spot, right, so from negative infinity to my vertex, or to this, not the vertex, but to the x-intercept here, right, all the way to the x-intercept here, which we said was negative 2.5, yep. So from negative infinity to negative 2.5, or I'm sorry, it's positive 2.5, all the y values are greater than 0. Then we had stop, and we say, okay, union, there's a break between here, because now I go below 0. My y values here are below 0, and then I start up again at the other side of my vertex here, which I believe was 3, and I go from 3 to 0. So I'm using my two x-intercepts here to determine where the y values are greater than 0. So the graph goes from negative infinity all the way to my first intercept here, which is negative 2.5. From 2.5 to 3, all the y values are less than 0, and then from 3 to infinity, all my y values are bigger than 0. So so to answer this last question, where is the y values less than 0? The y values are less than 0 from the first x-intercept to my second intercept is where they're all less than 0. Alright, so there's your second graph here. And again, these numbers, this one factor out nicely. If they don't factor out nicely and your x-intercepts end up with square roots or radicals, then just put it into your calculator, round to the nearest tenths, and just get an idea of where it's going to be on your, where more or less you'll be on your graph here. If your vertex doesn't end up with a nice number, you could also do that. The reflection points might be a little more challenging to find if your vertex ends up a square root, but I think for the most part these will all end up with a decent number here to work with. That's it. So that's how you use your A, B, C values. You find your x-intercepts, your axis symmetry again, your vertex, so we're always going to build the vertex. The x value of the vertex is always going to be the axis symmetry. The C value here is always going to be your y-intercept, just to review. And your A, B, and C, if your A value is positive, your graph opens up. If your graph's opening up, that means that there's going to be a minimum value because everything's going up from the vertex. So your vertex will be a minimum. I think we skipped down the last one. If your A value is negative, then it will be graphs going down, and you have a maximum at the vertex. Your x-intercepts, you're just going to factor. If you can't factor this, then you can use one of the other two methods. You can use the quadratic formula, you can use completing the square. Alright, then you can go from there. Probably the quadratic formula will probably be easiest, or completing the square, whatever you like. Remember your y value, it has a reflection point. However far away you are from your vertex, could always give you another value, which is why the x-intercepts follow that same rule. The x-intercepts are the same distance away from the vertex, right? So the vertex is in the middle of the x-intercepts. So ideally, if you know your x-intercepts, you can find your vertex, but just taking half of that. Alright, so here's an example from the notes. Hopefully this helps you and guides you through the next couple examples. See you soon.